Good afternoon, everybody. How are you? All right. My name is Jeff Freed, and we're here to talk about what was advertised as the healthcare showcase, and which is actually an introduction of InterSystems IRIS for Health, which was announced by Don Woodluck this morning. So we pulled a little bit of a changeroo on you, but it's effectively the same thing because the approach to using this new product and accelerating what matters, we're going to talk about a little bit about what it is, what you can do with it, and next steps. And really in the you can do with it, the best way to have you understand what you can do with this product is to listen to some people that have used it. So you'll be spared listening to too much of my voice, but Diane Steidler from Partners, George Rosello from Jackson Health, and Eric Widen from HBI will each spend about 10 minutes telling you their story as an illustration. Anybody that expected something else or would like to leave now, you absolutely can. There's lots of great content here. But I have the privilege of being the product manager for this new product, which in many ways is familiar to all of you because it has a lot of the same values, a lot of the same capabilities that you've been used to. You heard Don talking this morning about the basic vision, which is that we think there'll be a whole new generation of applications that are exciting new healthcare applications. The normalized health model, I actually got a lot of questions about this after the keynote. What is in InterSystems IRIS for Health includes an SDA health model, but if you want to have a unified set of information off of a single health record, that's when you really want to work with information exchange. So we have a whole family of products under the health share label, and InterSystems IRIS for Health is made so that you can get going fast with your own perspective, your own data. Obviously, key value for InterSystems all along has been reliability and speed. The scalability for IRIS is at a new inflection point, really through horizontal scalability in sharding. And if you want to know more about that, there are 2 sessions, one of which was yesterday, so you can watch that later, and one of which is tomorrow about scaling out. And then the idea of cognitive computing, just to bring it down to earth and product perspective, you'll hear several sessions here really around one of 2 scenarios. Using interoperability to connect cognitive services, and there are now some very powerful ones out in the cloud, or using IRIS as a way to serve up data, do data wrangling, and accelerate creation of machine learning models. So just to translate what is very high level into real product capabilities. And the plan, as Don explained, is that we've introduced InterSystems IRIS for Health. That is shipping now. I'll show you documentation. You can get kits, work with it immediately. TrackCare and HealthShare will use that as a platform sometime in 2019. The first member of HealthShare to do that will be HealthShare Health Connect, which will be this fall. And then we'll work our way through this. So it's not going to all happen at once. But what you're looking at in terms of the technology is where the whole portfolio from InterSystems is going. And then the wish list that Don presented this morning is genuinely what we're aiming at. If you want to know more about the FIRE application framework, there's a session right after this. There's also 3 other FIRE sessions and a experience lab specifically for building with FIRE. Who here is a developer, considers themselves a, okay. Who here has worked with FIRE other than in your home fireplace? Okay. That's good. And for folks that didn't raise their hand as a developer, how many of you are in IT, but not developers? And how many of you are not in IT at all, but more part of the business? Great. The fundamental framework of InterSystems IRIS for health is InterSystems IRIS. So there is nothing that you'll see in InterSystems IRIS which isn't available. And therefore, if you look, for example, at, I'll show you the documentation. Documentation for IRIS Data Platform for Health, which is available to you, by the way, only if you are a customer, has literally everything from IRIS. So has anyone been working with IRIS and developing to date? Okay, so that doesn't matter to you. But if you want to get to know it or work with it, it's building on top of elements that have been out and solid, many of which will be important to folks that are building interesting applications. Java Business Host is a new capability for integrating out to any kind of program you want in Java. MFT, Managed File Transfer, is a way for users to take, for example, drag and drop on their desktop into Dropbox and then have that show up in a production. So there's a lot of nice features, none of which we're going to talk about in this context because they're all things that you can learn about with InterSystems IRIS. And then the specific parts are in the healthcare solutions, working with a variety of both data models, registration, transformations, and protocols. So for example, there's built-in transformations from FIRE to SDA, from the various HL7 variants to SDA, et cetera. Everything in IRIS is in InterSystems IRIS for Health, and then a bunch of healthcare-oriented protocols, transforms, data models, and facilities, such as a FIRE repository. In general, the way that I have laid out roadmap is by audience. Right? Who was in this room just before this for the interface engineers presentation? All of that will also be in InterSystems IRIS for Health. So from the developer perspective, there's a lot of elements that are both native language, by which I mean ObjectScript and SQL, but also client-side languages, Java, C#, Python, Node, as supported languages, and therefore you can work in the language of your choice, developing healthcare applications. From the operations perspective, this is meant to be deployed in the cloud, on-prem, or in hybrid fashion. And we've worked a lot with containers as a way to develop quickly, deploy quickly. From the interoperability standpoint, as you saw in the last session, we've refocused on making the interface engineer's job easy and invested in a lot of tools now and a set of automation going forward. And last but not least, in analytics, there's built-in analytics, both in the BI sense, and by the way, many of these things will be familiar to you, but we've changed the names to confuse the innocent. So what was formerly known as Deep Sea, there's an analogous capability, which is really the same capability, called IRIS Business Intelligence. What was formerly known as IKNOW is now called IRIS Natural Language Processing. And all of those things are included. We have also added into InterSystems IRIS facility to work with data science stacks. Specifically, there's a Spark connector that scales out along with data shards. And there's a high-speed ingestion capability that scales out along with data shards. Because what we see happening is people coming in with streams of lots and lots of data, and then preparing it, and then making it available for data scientists. So I've talked a little bit about what InterSystems IRIS for Health is. Let's go through some examples of what you can do with it. And remember that this product was announced and released this morning. So none of what you're going to hear is production on this product, but they're experiences with the product as early adopters, experiences with the capabilities in a different packaging form, and hopefully will be, I found them a pretty exciting story.
Okay. So my name is Diane Steidler. I work for Partners Healthcare, and I work more on the integration and infrastructure side. So I'm responsible for managing a number of HealthShare, Health Connect, and now IRIS for Health systems throughout Partners. And today I'm going to talk about a pilot project that we've been working on the last few weeks, and that is moving our biomedical repository application to a Microsoft Azure cloud environment using the IRIS for Health product. Perfect. Okay. So first, a few words about Partners Healthcare. We're the largest integrated healthcare delivery network in New England. We have a number of hospitals throughout Massachusetts and now into Rhode Island and New Hampshire as well. We serve 1.5 million patients annually. We have thousands of physicians and nurses throughout our network, 73,000 employees. I believe we're the second largest employer in Massachusetts besides the state government. 13.4 billion in revenue, and 16 hospitals in affiliates, including a number of community hospitals, urgent care facilities, as well as our major hospitals, including our founding members, Mass General and Brigham and Women's. So let me start by just describing what this biomedical repository is. It's basically a very large database of biomedical data, and that data comes from bedside monitors throughout the Partners hospitals. This includes things like heart rate monitors and respiratory monitors. That data flows through these concentrators or gateways that are situated at the hospitals through HL7 messages, and they are processed by an ensemble production that's running in HealthShare. Those messages also are sent to Epic through bridges where they're persisted into the patient's medical record. But the data also goes to this repository, and the repository is available for researchers to do things like analytics and clinical decision support rules. And this repository has really been growing very rapidly over the past few years. It's currently 5.6 terabytes, and because we have a mirrored environment, we actually have 4 copies of this database. So we have a lot of data and a lot of costly storage that we've been maintaining. So in fact, that's our first motivation or goal for moving this to the cloud. The idea is to get more flexible growth of not only the database, but other system resources, and cut down on cost. Secondly, we want to migrate to the InterSystems IRIS for Health platform, and that's pretty much what this pilot involved, is migrating to a cloud infrastructure, leveraging some of the capabilities in IRIS for Health, like containers and the Cloud Manager tool. And I'll talk a little bit more about that in a bit. And lastly, just to gain some experience with cloud technology, because that has been new to us, our partners, and be able to leverage this expertise to use for future applications. So we started out with a bunch of requirements for which we would deem this pilot a success. Certainly security is very important, especially if you're moving patient data into the cloud. So Azure really provides a lot of security features. We also started encrypting our databases and using SSL for connectivity. Performance is very important. We want to ensure that the messaging is fast enough so we don't see queuing and the databases get updated in a timely manner. Availability. I'll talk about our migration process in a few minutes, but since this is a live application, we want to make sure that when we do migrate it to the cloud, and this, again, it's a very large database, which took actually almost 100 hours to transfer to the cloud, we want to make sure that the application is still available. So we designed a migration strategy around that. Manageability. We have years and years of tools that we use for monitoring our instances and managing them. So that was really a requirement that we could continue to manage the cloud instances in the same manner as we do our on-premise instances. So integration back to those tools was important. Robustness. Obviously, we need it to be stable and robust and scalable and not have any adverse effects on the existing systems. I spoke a little bit about extensibility and best practices that we're still really putting together. Deployment, I'll talk about the ICM tool, which allowed us to really very quickly and easily spin up an infrastructure in a Microsoft Azure environment. And then cost. We found that analyzing costs within Microsoft Azure is more straightforward than assessing your costs on-prem, because Azure actually has some nice tools available that'll break down the costs and give you monthly reports, but it's a little bit more complex trying to get that information for your on-premise system. So that's an ongoing task. Okay, so we installed IRIS for Health. It was a pre-release version, and we loaded up the application and configured the interfaces and really didn't have to make any kind of changes at all. It pretty much just worked. Everything worked perfectly. There were no surprises there. We configured our ECP connections back to our on-prem systems so we could use those management and monitoring tools that I mentioned. And that was fully supported and backwards compatible with, I think we're running like 2006 and 2007, 2016 and 17 instances. So that was backwards compatible, which was great. Some of the commands and the APIs in our tools we had to tweak a little bit because they were more IRIS specific. But the changes were pretty minor and intuitive. And then the performance was really what we see typically on-prem in terms of using the portal and the command line in the studio. So this is really how we migrated this very large database up to the Azure cloud. And while we were transferring the database, what we did is we, whoops, I'm sorry. Oh boy. One more. Okay. While we were transferring the database, and again, it took 100 hours, we queued up the messages in our IRIS for Health instance. So those all queued up. And then once the transfer was complete, we enabled the queue, and those messages flowed into the repository up in the cloud instance. And that way it's synced up with the on-prem database. Okay? And so the idea is to run in parallel for a while, assess the cost, assess the performance, and then dismantle the database on-prem. So we're running the biomed repository completely in the cloud. And when we set this up, we actually used the Cloud Manager tool, and it made it very easy to really define your infrastructure by simply editing these JSON files, which you can specify the storage, for example, the amount of memory you want, the number of cores, what geographical region you want to run in. So we used the Cloud Manager tool, and it took less than 10 minutes, I think, to spin up all these resources in our Azure cloud, including the virtual network, the storage, the virtual machine. So it was super easy to use, and we could make tweaks to it and get updates to the IRIS container and reprovision that quite easily. And then copying of the repository, again, that took 100 hours. We had to first encrypt it. No, first we had to convert it from AIX format, which was big endian, to little endian. Then we had to encrypt it. We had to split the database because it was too big for the Azure copy tool to move up to the cloud. So that took several hours as well. And then finally moving it up to the cloud and into blob storage and moving it out of there into our file system. So there were several steps involved in moving that file. And then again, we're keeping the repository in sync with an HL7 message over a public network. And so this was phase 1 of our pilot for our non-production environment. And we're going to move on to our next phase, I think next week, and get the production environment going and get that all set up using the same configuration that I explained here. And we're going to look into sharding, because we think we can take advantage of that feature, given the size of the database and the queries that we're going to be doing on it, and go from there. So, any questions?
Just one. As you were copying the 100-hour copy of Biomed to the cloud, you didn't put messages for it, but you also said you had no downtime. So I presume that you're actually sending a message two places, one to your live system and one to the cloud to be queued up and consumed.
Yes, exactly. Yep, the same message went to both places. So once we enabled that queue up in the cloud, they were in sync.
And is the storage flexible? I've not worked with Azure, but is the storage flexible there so that you can sort of rent the storage for the time you have to build up this queue, consume your queue, and let go of the storage again? Or my experience, I'm afraid.
In terms of cost?
Once I got some storage, I don't get rid of the storage. That's
Right. Well, the storage is there, and those messages are still there until you purge them. Well, yeah, so, the files are still huge.
Your current database now, you have no use for the storage space that you've been holding all your queue in. You can just give that back and be free of the cost?
You can give that back, because the nature of the .dat files, they grow, and you have to sort of compress them, and that'll give it back to the OS.
Well, but the queue is not, I see it. Okay, I got it.
Yeah, because there's another file where the queues are stored.
So, Jackson's been around for a long time. We just celebrated 100 years in Miami, so a lot of history there, as well as a lot of legacy systems. So let's talk a little bit about OverWatch. So OverWatch is a solution platform that we built on top of our HealthShare instance. It leverages a lot of cache classes to interact with the Ensemble messaging layer or Health Connect messaging layer in order to kind of produce this solution platform. It's capable of accessing all of our interface data that goes through the engine. It also creates its own prepared data sets, and its primary purpose is for real-time analytics, alerting, and monitoring. It also has dynamic workflows and business processes that we can do to kind of automate things. And we developed it primarily as something that we could iterate very quickly off of. So the platform itself is really just there to serve as a springboard, and then we iterate quickly on individual solutions. So when we launched in January, we had essentially 2 pilots that we partnered with. So the first one is population health, ED, high utilization. We have a large amount of unfunded care in Miami, And a lot of times these patients come into the ED and use their ED essentially like a primary care facility. So our population health team was on the verge of starting an RFP for an application, and we saw this as a good opportunity to inject ourselves into the conversation and offer an alternative approach. So instead what we built was an OverWatch layer that essentially tracks the population health patient list and looks for any encounters where a high utilizer is coming into the organization. We identify the point of entry, whether it's the ED or one of our satellite facilities. We dynamically look up the case manager and send them a text message as well as an email. Gives them all the information they need in order to reach out to that patient, intercept them, and get them into an appropriate line of care. In addition to that, once they're enrolled in our population health program, we're able to track them through the process, see that they're attending their appointments, give the case manager a heads up whenever they need to maybe go and attend with the patient. Any time that they show up in any facility, we continue to monitor their care to make sure that they're getting all the care that they need and that they're also following along with the program until graduation. That program got us, kind of like a lot of trust with the organization in terms of using this kind of solution in place of a traditional application. In its first year, it's reduced our net subsidy costs on these kinds of patients by $2 million, and next year it's forecasted to hit $6 million. So it's had a direct financial impact, and we didn't have to spend really any money to get it up and running outside of 6 weeks of time for my team. And if we attempted to probably procure an application, especially being a public organization, we'd probably still be in the procurement process right now. We wouldn't have anything actually live. So that led us to a second product that we sent off in April, and that's outpatient appointment reminders. So Jackson was a little behind in the times when it came to reminding patients. We used paper mailers and a robocalling service. Anyone who, I don't know about you guys, but I check my mail about once a month. So paper mailer's not really effective, I think, in today's day and age. We wanted to go digital. So again, the organization was looking to, procure a solution. We were able to kind of get involved and said, hey, listen, we're so successful with population health. Why don't you let us take a stab at appointment reminders? So in this case, we integrated OverWatch directly with our data warehouse as a supplemental data source. And we were able to extract all the patient scheduling information in addition to the real-time feeds that we had coming from our EMR. And we're able to remind patients with information based on their appointments, dynamically populating things such as the language. We actually support 3 languages on the reminders that we send. We put the start time of the appointment based on the line of service it belongs to. One of the things that's really challenging, especially at Jackson Memorial Hospital, our flagship, is it's a 30-building campus. It's monstrous in size. Everyone gets lost there. So one of the things that we did was we dynamically look up based on where your service location is to where your parking garage should be. And we tell you what garage to park in, so that you're not just aimlessly driving around the campus trying to figure out where to park. In addition to that, we actually include pictures of what the parking garage looks like, as well as the building that you're looking for. So, there, thank you. So I have some samples for you. One of the things that's really challenging with presenting these kinds of solutions is there's nothing visual to it. So it's very hard to show people. When you have an application, you have all these forms and fancy graphics. When you do an integrated solution like this, it's really just a feel-good thing. So I have some of these outputs here for you to look at. This is appointment reminders, as I was just describing. We intentionally made it a very simple email because we noticed a lot of patients like using their phones. So this is very phone-friendly. And since launching, we have tons of times that we run into patients and they show us their phone and they say, hey, this is my appointment. I'm headed here. Am I in the right place? Yes, you are. And it kind of guides them along. And this looks like one cohesive message, but it's really been assembled dynamically, piece by piece, depending on all the different components of the appointment. And you can see there some of the pictures. Our marketing team had a lot of fun taking photos of our hospital, making it look good. After 100 years, it doesn't look too bad, right? And then population health. So this is more internal messaging and very pilot-y in feel. So it has some very basic information here. You can kind of see what the text messages look like. We're texting phones that are not HIPAA-approved secure devices, so we don't include any patient information in there. We have a very ugly ID that was temporarily included just so that we could help troubleshoot and be able to track it back. For those of you HL7 savvy in here, that is a message ID. So it helps us link to the actual message that created the trigger to begin with. And on the left, you see just some basic information. We've expanded it since then to show some historical info. And we're actually working on phase 2 of this, which should hopefully bring it into full production. So we use Health Connect. In this solution, we're using Health Connect and we're using cache. So we have a cache layer to it. That's actually where OverWatch lives, is in the cache layer. So, okay, so this is a long story, but the short version is that we bought this when it had a completely different name. So when we got it, it was HealthShare Foundation, which is just how we're used to referring to it. Since then, I believe the Health Connect name got introduced. So depending on when you acquired your installations, you may have different names that you use for it. So internally, we actually rebrand everything, so we don't ever refer to it as HealthShare or Health Connect. So I'm just referring to the individual components just for, to make it easy for everybody. But we just have one installation. I don't want anyone to think that we have like a separate installation that's talking to an Ensemble/Health Connect. It's just one installation, but we built OverWatch at the cache layer of it. We did not build it in the Ensemble Health Connect layer. Any other questions? All right, great. Thank you very much.
So I'm Eric Widen, CEO and co-founder of HBI Solutions. We're a healthcare analytics company that has a strong focus on predictive risk modeling. We're partners with InterSystems, and we've built our solution inside of HealthShare, and we've been working with the InterSystems team to understand IRIS and where IRIS is going to help us as we build our product out in the future. And so I'll talk a little bit about our solution and then talk about the workflow and where we see benefits of IRIS helping us out in the future. But the core of HBI is basically the team is built of machine learners and data scientists and computer scientists that are taking client data in, running machine learning processes on them, and developing algorithms that run in near real time on client and patient data sets to identify risks for patients for untoward events in the future. So we predict things like cost and are they going to show up in the inpatient setting? Are they going to have a readmission? If they don't have a chronic disease today, they're going to develop one in the future. Are they likely to have a high cost, high morbidity event like a heart attack or a stroke? And so we've got over 30 plus models that run in production environments to help really alert clinicians that a patient has these risks and to enroll them into the right care program is our core capabilities and competency as a company. We leverage the HealthShare platform because the starting point for us is an integrated, centralized, normalized data set that we can then take and run machine learning on it, and it's also that same data set where our algorithms run. So as new information comes into HealthShare, those risk scores fire in near real time as HealthShare gets updated with patient information. Our risk scores fire within HealthShare and then update that information. And so just a little bit why we're relevant and why we're good at what we do is there's a couple components. One is we're live on over 20 million patients today, and so our team is literally almost 24/7 either implementing, managing, supporting risk models that are running in near real time on client data set. We use what we call custom machine learning as a service, and so what that means is we basically rebuild algorithms based on a client data set. And we have a very eclectic mix of different clients. We have ACOs, we have health systems, we have insurance companies, we have self-insured employers that we're all working with them, and each of them have very different data sets available to bring to bear to run machine learning and develop algorithms on. And so by developing specific to that data set, you're basically tuning and getting the best results possible for that data set. And then secondly, there's local norms within a data, right? Certain patient populations in a certain geography are going to have things that are specific to them that aren't really relevant to other parts of the country. And so by doing that, we're able to almost guarantee that we can get the best risk insights possible on patients. And any time, and we do this a lot as part of the sale process almost, any time we look at what a client's doing today, whether it's an internally generated method or whether it's another third-party tool, we've been successful in identifying at least 10x more patients at the outer risk levels, either people that are at a risk threshold or that are rising in risk. And that helps demonstrate from a performance ability why we're able to give better insights, but it's also important, the whole reason that's important is that you can better assign your care teams out to patients based on risk. And so that's what we do. And so we're largely an engine that's a smart engine that runs inside of a platform, in this instance HealthShare. So as HealthShare is running with data, our intelligent insight engine is running inside of HealthShare to update these scores. And we're very research focused, and so the company was founded by myself and researchers that are still on faculty at universities and we've taken a very research-driven approach. And so we've got over 13 publications on our models that if you look at our website that help demonstrate our methods and how we've gone about developing and thinking about risk models. And so why HBI and InterSystems? And so as I talked about, the real-time centralized, normalized data is very important, right? So all that heavy lifting happens within the HealthShare platform. And if you think about risk model approaches decades ago, which really haven't changed till recently, they were largely built on claims data, which at best is 30 days old. A lot of times it's going to be 60 or 90 days old. And they were static models, right? You had these companies that developed one model based on a single data set and just applied it to the entire population, right? So by getting, what's changed over the time is that electronic medical records are now more available. You've got access to real-time data. And then computing power is certainly much more powerful right now and getting more powerful. So that those things allow you to do much better risk stratification on patients. And then the ability to alert clinicians in real time. So we've got a certain set of our models that run in real time. So as a patient gets admitted, we've got a series of acute models that predict 30-day readmission. Are they going to have sepsis in the hospital? Are they going to develop an infection? Are they going to die in the hospital? So those all run literally every 10 or 15 minutes as a new clinical result back into the EHR to help inform the acute team that these events could happen while the patient's in the hospital. And then secondly, we've got a series of population models. So if you've got an ACO or a set group of patients that you're responsible for managing, those basically run nightly to predict the future events of those patients. Are they going to show up in ED in the future? What are they going to cost? And are they going to develop a disease? So just a little bit about the workflow and kind of where we see IRIS helping us, right? So as information comes in, right? So today, we're largely using data that's generally available in electronic health record or generally available in a claim system. And that's what we have access to today. But as information expands through devices and other tools that are either patient-generated or machine-generated or monitoring, that's just going to keep expanding. So the amount of information we're going to get on patients, whether it's social determinant type of information or just social behavioral type of information, that's going to continue to expand. So the ability to have a scalable data set to bring in more and more information is going to make the risk modeling much more richer, and it gives us the ability to find new insights on patients as these new data sets come in. And so as information comes into HealthShare, it flows to our analytic instance, and out of the HBI analytic instance, we basically take 3 years of data, 3+ years of data, into our machine learning environment, and then in the machine learning environment runs on multiple years of data and then does a series of blind prospective testing on the data, and out of that are algorithms that are basically deployed back into our analytic instance, and these update the patient's risk as new information rolls into HealthShare, into the HBI environment. And there's a couple ways that can be viewed. There's standard UIs that are developed where you can look at a patient's risk, and I'll show an example of that. But it also flows back into HealthShare. So those risk scores have been built out on the data model within HealthShare. And so that information can then be sent either into smart programs or clinical event notifications or workflow integrations that are out there, and they can also be integrated back into electronic health records through HealthShare as well. And so that's the general flow of information today. And so, the ability to get more information in, so as IRIS becomes more part of HealthShare, that will take advantage of those capabilities of IRIS. And then we're working with the InterSystems team right now to figure out can we conduct machine learning all within the same platform as well. So it'll be like a single platform that can do both larger, more real-time data, bring in larger data sets, and also do machine learning within that environment. And so with that, I'll give a quick demo of just the solution itself. And so in this example, this is a population health tool where you've got 148,000 patients that you're managing proactively to keep them healthy at home or healthy at work. And you want to prevent events from ever happening. And so to do that, you want to understand what's going to happen to the future of these 148,000 patients and which ones are at high risk for certain events. And so across the top, you've got retrospective information around retrospective cost, utilization on the inpatient and ED side, and the death rate of the population. And in the next row down here, you've got where the risk models come in. And so here you're looking at distribution charts of the 148,000 patients looking at the number of people in risk bins from low to high. And so in this example for future cost model, you've got 42,000 patients out of the 148,000 that are going to cost on average $700 in the future. And then each bar represents the number of patients in higher future cost bins all the way up to the highest cost bin in this example, 35,000. So you're basically looking at a distribution of your population from low to high risk for future cost. With the exception of the cost model, All the other models are calibrated to probability of the event, and they're mostly event-based models. And so here we're looking at what's the likelihood of an inpatient admission in the future 12-month period. And so here you've got 90,000 patients between 0 and 10% risk to have an inpatient admission in the future 12-month period. A group of 44,000 between 10 and 20, so on and so forth, till you get to the outer risk ranges closer to 100. The ED model works very similarly, different model, focused on future likelihood of an ED visit in a future 12-month period. So again, you're looking at the distribution from low likelihood of an ED visit to high likelihood as part of that. And so organizations are using this to figure out how many people do I have at different risk bands as I think about assigning care teams to people based on their risk scores. And then we're showing a mortality risk here too, and we've had interesting use cases around palliative care discussions and proactive end-of-life discussions as you identify people within your population that are likely to expire in the future. And then we've got a series of other disease models that are part of that. So this is an aggregated view. From the aggregated view, you can get down to a patient view. And so here, we're going to drill into the 156 patients that are between 90 and 100% risk for an ED visit. This would subset the dashboard. So with filters, you can say, okay, I want to look at all the people that are at that outer ED visit risk range. And so this is set on that. You get 156 patients that qualify. What's interesting here, if you look at the retrospective ED visit rate, right, the average for the population, which you might not have picked up on the previous slide, was 400 per 1,000. This high-risk group had basically 18,000 visits per 1,000 or 18 per person historically, right? So a super high ED utilizer group retrospectively, but also prospectively, right? So they're almost guaranteed to come into the ED in the future. And also what's interesting is the cost risk of these patients, they're all in the outer cost band. So you know you're dealing with super high ED utilizers, but they're also going to be much high cost, in the highest cost bins in the future as well. Then you can drill into a patient list. And so here we're looking at each row is a person, and when you start looking at the patient level, you're looking at all the risk scores for a patient. So this is sorted by ED visit risk from high to low, and then we're going to drill into a single person. So we'll take the highest risk ED person. You see scores here in red. The red scores mean it's elevated from the norm of the population. And then from a transparency standpoint, we're going to give you what the model picked up in terms of a score, and then we trend that over time and show if it's elevated. So this person's always been elevated for ED visit risk, actually rose in the last month. You're going to manage a person, you're going to pick a person because of a single risk, but you're going to manage all of their risks, right? So this person's also at risk for high future cost, risk of an inpatient admission, at risk for stroke, mortality. We see 100 means they have CHF and have CKD in this instance. But we're focused on this person because of the high ED visit risk, and then drilling one more level down. We're going to give you everything the algorithm picked up on a patient, right? So this person, super likely to show up in the ED, and then here's why, right? So they had 9 ED visits historically. The inpatient utilization is also driving that. We see some factors influencing health status, some chronic diseases as part of that. Mental health issues are showing up when you see anxiety disorders and so forth. So basically, and this would go on and on to show other features. Basically, each algorithm has hundreds and hundreds of features in it that it's scanning the population for to do that. And so the ability to then bring in larger data sets and more information and so forth, we think this will continually allow us to be more real-time and then better at the risk stratification as we start expanding the scalability of the platform itself.
I will be presenting at the AI Forum tomorrow afternoon. So thank you guys for coming. If you're interested in doing in more steps, try InterSystems IRIS for Health. It's available now. Any of the IRIS experiences, and there's 4 of them on the InterSystems, learning.intersystems.com, apply, including a machine learning one, and talk to people at InterSystems and go build amazing stuff. Thank you very much. We have out of time really for interactive questions, but I'm sure everybody here would love to talk more with you here or in the hall.